Okay, so I'm going to talk about microservices. This is the agenda for today. So I'm going to talk about what are like microservices, why you need microservices if you need them, what you need to make them work correctly. And then I have two more points. One about like advices if you need them. And maybe we will have also a small session about questions. So just more information about me, what I do, how I earn money. So I work for this company. It's called May.com. We are an e-commerce. We are based in London, but we work also in Germany, in France, in Switzerland, in Netherlands, I think. And our backend infrastructure is completely based on top of microservices. So we have more or less something that I can call 50 services. We have 102 AWS instances running just in production. And we have a deployment running on 3 different hubs. So we have test, UAT, and production. And we have a very fast cycle for deployments, and we usually do like 15 deployments daily. So what are like microservices? So when I was like younger, I used to develop using the LAMP stack. So you had Apache, you had your PHP application based on Linux and MySQL. So it was more or less like this. So you had like Apache from like the proxy server, and you had your monolithic application, right? And I mean, initially you can think that it's like simple to develop, to test, to deploy, and to scale. But after spending like years running this kind of application, you just reach a point where you start to see that this is not really true. I mean, it's probably easy to develop, but it's really hard to scale, and it starts to be very hard to deploy when you have multiple services connecting to different domain. So for example, here you can see that we have like the storefront UI, we have the accounting service. So if you want to deploy just a part of the application, you cannot just do this. You need to deploy the entire stack altogether. And here we go with microservices. So you can think about the same application, but you just separate their different business domain. So for example, you can say that you have the catalog microservice, you have the accounting microservice, and you have the store UI microservice, and you just separate the business domain. And I mean, it's pretty nice. And what you get is from just one sheet to multiple sheets. So when you switch from a monolithic application to a microservices application, it's a different way of deploying and testing your things. Now I want to define somehow what is a microservices. So these are all definitions that you can find in the Sam Altman book about microservices. So a microservice is a small autonomous. I mean, microservices are small autonomous services that work together. They are thin and decoupled. So, and that's my definition. You can write them or rewrite them in 2 weeks. And the separation between your microservices is needed because, in this way you increase the resilience of your service. So if one microservice is down, the other one can run without worrying about the others. So basically, can you make a change to a service and deploy by itself without changing anything else inside your architecture? So you can deploy service A without worrying about service B. So this is why you probably need microservices. And here we go to the next point. So why you need microservices? Before giving this talk, I was thinking about this, and I tried this way. So I didn't know, and I decided to Google for this. And I don't know if you can see the picture, but you get like 30 million results just for this. And if you work for a corporate, maybe you want to know why enterprises need microservices. And I think you should be careful, because it's not a trap, it's undoubtedly a trap. So the point is that, I mean, you will get like a collection of blog posts, usually with 10 or 15 points. And I would like to discuss this with you. So first of all, when you try to work or read about microservices, one of the points is simplicity. So because you start to have a smaller application, it becomes easier to write them, of course, and to maintain them. And this is totally true. So because you can focus just on a specific domain, the logic of the microservices is simpler and it's well contained. So this is +1. Another reason that you usually see around is freedom of using, multiple languages and with a complex stack. And this is red because it's not true. If your team is a Python team, don't do like us and, okay, let's do data pipeline in Haskell. It's not a great idea because after some times, the only developer that knows about Haskell will leave the company and then you have like a microservices that is like, okay, ready to be commissioned. Another reason that you will find around is speed. So application because, this part is wrong, but it's just easier to implement new services because the service is small. It's just well contained, and you can just it's totally separated from the other microservices, so it's just super easy to implement a new service because you don't have to worry about the other stack. So this is another plus one. Another point that you can read about on the internet is about testing and QA. Because you think that each microservices can be tested individually. This is partially true because at the end they work together. So you want to check if they cooperate together because you probably get information from another service and use this information in another microservice. So at the end you want to check if all the microservices work correctly together. So testing, yes, you can test the microservice individually. But if you want to do a proper testing, and maybe I can talk about this later, it's still really hard. You start to have like integration tests or acceptance tests, and they start to be really complex. Another things that you can read about the reason to use microservices is about teams. So my company is based in London. I work remotely for them, and we have also a local team in London. And it's quite easy. If you start to grow as a company, you can separate the team and you can put like multiple services like inside the team and they can just focus on this. This is fairly true. So far it worked really well, at least at Mail.com. But on the other reason, this is the Conway law. So don't think that the way in which your architect your service will change your company. Usually it's the other way around. So if your company is structured like in a way that doesn't help to have microservices, trying to implement this from the ground to the top won't work. So you have to have like the microservices mindset and also in the management. Another reason is isolation, resilient, and flexible, because if one microservice fails, the other one, they can still run. And this is partially true because it depends on the way in which you implement your microservices. So if the communication protocol, for example, between your microservices is built on top of HTTP and you don't use like a service mesh, you probably have an issue because if one service is down, then you will have the latency, then you will have like 404, things like this, and all the other microservices will stop. Another reason is security. So you simplify security monitoring because the various parts of an application is isolated. So you separate what was like before a monolithic application in multiple services, and now you have let's say the database are also constrained, so you should worry less about security, but this is partially true because you see this is in yellow, because then before you had like one problem and then you have X problem, and you have to think about X security problems like the roles or the permission for the database access. And another point is code boundaries. So the code is organized around business capabilities. This is not true. It depends specifically on your company and on your teams. Like I said before, you cannot implement the structure of your company from the software. It's the other way around. And another point is high scalability. So because you have single services, you can just scale them and it's going to be super easy. This, again, it's partially true. It depends on the way in which you implement your microservices. For example, at Mail.com, we have services where we have just one consumer, and we code the service to have just one consumer. So we use something similar to Kafka. And for specific streams, we would just think about having one consumer. So it's really hard to scale this service because we cannot have like another service. You can just scale the service like vertically, so we can just have bigger resources, but that's all. So again, this is partially true. It's just easier if you want to scale your microservices, but it still depends on the way in which you architecture your services. So back to the initial question, if you really need microservices or not depends on your specific context and business. I'm pretty sure that if you have just one team, it doesn't make any sense to have multiple services, and working with just a monolith application is just fine, because there are also many side effects of having or working with microservices. Now, a very interesting part is what you need to work with microservices. So basically, you need two things. You need to master CI, so continuous integration and continuous deployments. So if currently to deploy application, you SSH into your machines, or you very often use like Docker exec. It's not the proper way, probably. And you need to have the right infrastructure in place. Basically, you need to have a cluster infrastructure. We use Nomad. It's a software by HashiCorp. It's similar to Kubernetes. You can use whatever you want. Docker Swarm, Kubernetes, or Nomad, for example. And another thing is that you need to have a very strong DevOps culture. Not people, but culture. So, for example, we are in charge of the end-to-end deployment of our application. I mean, from the way when we start to thinking about the application to when it runs in production. And we are also fully in charge of, monitoring, deployment stuff and all these things. And what we have, for example, is one-click deployment. So we just select version of the Docker image, because all our services are like containers at the end. We just select the version and we put the version inside Tower and we deploy the application selecting the environment. So again, you really need to be into DevOps. You really need to be into this release process. And if you think you can work with microservices and having really long release flow, weeks or months, it's probably not going to be a good idea. I think you really need to have a fast feedback cycle. And here we go with the advices. So the first one is that, okay, before you had a monolith application and now you have multiple microservices. So now you have X problems. So again, if you have just one team, it doesn't make any sense, at least at the beginning, to work with microservices. Another thing is, and I said this before, is so when you have microservices, you need to communicate between each other. Usually you put a queue in the middle. It could be Kafka, it could be Redis now, RabbitMQ, whatever. And using just plain HTTP protocol is not a good idea. So if you want to do like HTTP calls between the services, I consider this an anti-pattern if you work with microservices. You can use HTTP protocol if you put a service mesh. Another point is that it's completely different way of developing services if you are coming from Django or from Flask. For example, we don't use Django, we don't use Flask, we just have plain Python application, and we just read from an event stream. Another point is it's very easy to do it wrong. I mean, we are still iterating over this. I think we started using microservices like 2 years ago, and we are still in the process of iterating over this. And another point, and for example, this is something that we did it wrong because we are using JSON as a schema, is that you need a schema. I mean, if you use a message queue, Kafka, for example, you really need to have a schema. So you need to check what enters your message queue and what you get out of your message queue. And currently, for example, in our case, it's not really enforced. Another thing is specifically related to Python is async.io makes writing microservices extremely easy. So our infrastructure is based on top of async.io. But don't forget that CPU-bound tasks are still blocking. So just be mindful about this. And testing is still very hard. You think it's easy because you can just test your service, but it's just one part of your testing process. And the last point is, I mean, if you start working with microservices, you will see like duplication of data between different services. So my advice is just embrace data duplication. Storage is cheap, and you want to avoid like multiple queries or sharing access between different databases. Because, for example, we use one database for each microservice. So just go with this and don't worry too much. And the last thing I want to say, 4 cool things that you can do with microservices. So the first, and don't get me wrong, you can do testing in production. It's really cool. You can do this with microservices because you can just move microservices around from test to production. The other thing is service mesh. There is Linkerd from LinkedIn, and there is Envoy from Lyft. You can check this project. The other cool thing is Redis streams. So if you like streams or message queue, but you don't want to use Kafka, you can use Redis now. And another thing that is super easy with microservices is doing canary releases. So you can just do like green, blue releases. You can move services all around in a very simple way. Okay, so this is everything I had. I think I was quite fast. And if we have time, I'm happy to take questions.
Yeah, we have time for 2 quick questions.
Thanks.
Yeah, hi. Why do you consider HTTP as an enter pattern?
So because if I'm a microservice and you're another microservice and you do an HTTP call to me, but I'm busy, you're going to get a timeout. Right? And if you consider that you have multiple microservices, it's going to be a mess. And you want to have like an async pattern of communication, right? Does it answer your question? Okay.
Any other question? Okay.
Hi.
How would you suggest to do a move from a monolithic architecture to a microservice architecture?
Just one business domain at a time. So you can just take a part and you just split in this way.
Follow up to the first question. You said HTTP requests are an anti-pattern unless you use a service mesh.
Yes.
What is a service mesh, and how does it resolve that problem?
So basically you have your microservice and you have something, I mean, it's called the sidecar partner. So basically you're putting something like together with your application and you're going to communicate with this small thing called sidecar. And it's basically it's a proxy. So it will do this for you and it will communicate with the other microservices and all these things. And I mean, it has also a retry policy and all these things like secret break. So you don't have to worry about timeout.
Okay, thanks for a great talk, Christian.
Yeah, thank you. You're welcome.